All right, so we are on lesson 8-2. Unit 8 is about exponentials and logarithms. So today's date is April 17th, 2019. Make sure that you have the date and your name on the paper. Chris does not have the date on his paper. Let's see. James is still writing his name. Make sure you have your name and date on your paper. All right, so let's start off with some vocab and then move on to the I notice and the I wonder. So an inverse function is a function that reverses another function. So this should be kind of review. We did spend about 2 to 3 weeks talking about inverse functions. There's the horizontal line test, all that stuff. Nod your head if you vaguely remember horizontal line test, inverse functions. Okay, so we're talking about inverse functions more and more now. All right, I'm curious who has some cool things that they noticed. So I forgot to pass out cards. Who wants to do that for us real quick? Go for it. All right, quiet raise hand. Quiet raise hand. What did you notice? Or what is something that your partner noticed? You can use either or. Stego.
Okay, this could be completely wrong, but the red line, like if you flip it over, it would like go on the blue line.
Flip it over
like,
what?
I don't know, just like
over. Over this. Oh, okay. So like if I folded it across this line, then they would match up.
Yeah.
Okay. So how do we want to say that?
But that's what, like, I thought.
So the red line. So how did you say that again? So the red line is.
I said if you fold the red line over that black dotted line, the points can match on the other. Like on the blue. I don't know. It's just it's like. Okay, I'm done.
The dashed line is the blue one. Very, very cool. All right. Yeah, I really like that observation. So coming back here, coming back to Algebra 2. What is something else that someone noticed? Andrea, go for it.
Wow.
So and if you don't have either of these, write them down. We might have ran out of room. You can write them off to this side if you want. The x and y values are switched. Yeah. I did not see a binder left. What was something else that you noticed? Gio, go for it.
I just love this.
Okay, let's see.
Alright, excuse me, I'm trying to speak. Alright, this one added by 1, this one added by 2, 2 to get 4.
Okay.
4 and 4 gets...
Up here to...
Yeah, A. So there you go.
Okay.
And I think the next one is going to be 16.
Okay, so 4, 16?
Yeah.
Okay, yeah, that is a great observation. So you can say that the y-coordinates, coordinates spelled with 2 O's, coordinates, double.
On the blue line.
On the blue. B-L-U-E. Very cool, yeah. And that makes sense because I wrote even here that our equation is 2 to the power of x, so that means you're going up by powers of 2. 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, which would be 16 next. Yeah, that's awesome. What else did we notice? Anything else? All right, what did you wonder? What was a question that you wondered? What questions did we have?
Oh, yeah. We're going.
What questions did you ask? I'm curious. What did you ask? Any questions? No one wrote any questions at all?
Oh, yeah, I have one.
Okay, who has a question that they would like to share with the class? Yeah, Gio.
What do you want?
Okay, I'll tell that in a sec, but maybe someone already asked my question. What questions did you ask about this graph? No one?
Does the black dotted line matter?
Oh, yeah, that's a great one. Does the black line matter? I love that question. Okay. Another question. Who else asked a question?
Dude, I got you right.
Oh, God.
Hey.
Like,
Alright. Why is the blue line dotted and why is the red line solid?
Okay. The answer to that, I can answer that right now, is because you guys don't have a color copy, so the way that you can differentiate between the two lines, the way that you can differentiate between the two lines is you can say, instead of the red and blue, you can say the dashed and the non-dashed function. Any other questions? All right, here's a question that Mr. Sindel had. I know what this function is. What is my question going to be then?
What's the red's function?
There it is.
What's the red's function? That's one.
I'd say.
What function represents the red?
That's what I just said.
No. I'm gonna
All right, you want to hear another question that Mr. Sindel has?
Wait.
Is it indeed true that Stego's observation that if you flip this over the
I don't think so.
dashed line that they are exactly the same, or are they only roughly the same?
I think roughly. Mirror?
Yeah,
Oh,
the mirror.
mirror. We're starting to use better words here.
I
Mirror.
said that.
You
Yeah, she said that.
said
Yeah.
that? Okay, sorry. Mirror. Does anyone know the geometric word for mirror? Starts with an R.
Reflection.
Oh
Oh
my
my
Yeah, so on this one, can we do an arrow right here and use the word reflect?
Did you?
Yo, can you go back up?
All right.
Oh,
So that is kind of the main takeaway that I want you to see from this graph. From the blue to the red, all you're doing is you are doing this reflection. So I'm going to write this down here and give Andrea the XP. This inverse function, by the way, these blue and red lines, the big reveal here is they are inverse functions of each other. Blue is the inverse of red. Red is the inverse of blue. So an inverse function reflects over the line. Ooh, what was that line?
X.
It was y equals x.
Oh.
Yeah.
Okay.
So Stego, some more XP. Andrea got the word reflect.
Geo, Chris?
Yeah, and that's kind of a cool thing. And then, of course, I'm going to ask that question that toddlers always ask, why? Why is it y equals x? Does anyone have an idea?
Wow.
Yeah, Fiona. Yeah, exactly. So that is the reason why it's y equals x. But I guess so you answered it perfectly. I'm going to give you XP. I asked the question horribly. Let me ask the question better. Why is the inverse a reflection over y equals x? And it has something to do with what, who said this one? The x and y values are switched? Geo? It has something to do with that.
Because you flipped the yeah.
If you flip the x and the y coordinates, that means the x and the y change. X is equal to y, that means
Right.
flipped, y is also equal to x.
Ah.
So these points here are flipped, which means we are having this equality, y equals x. We're actually changing these. This is the same thing as x equals y. All right, cool. So we're getting that conceptual understanding. We're getting more and more conceptual understanding. Okay, so let's do a table. We'll get a ton of XP here. What is the y coordinate for this function y equals 2x? Looking at the graph above. Geo. 1. I need another volunteer.
2.
Next one is
2.
quiet raised hand. Chris.
2.
Easy XP. Thank you, Chris. The next one, the y coordinate is James.
4.
James gets some XP, and I have his card. And the next one for 3 is Geo. 8. Thank you, Geo. All right, so this unknown function, notice that I left this blank. I left this blank because we haven't talked about him yet. But if I talk about this red line, what are the x and y coordinates? Someone give me the first point.
Wait, isn't it the same but flipped?
It is, yeah. So give me the first point.
1.
1 comma,
0.
0.
then
2.
2, 4,
1.
1. 2, 4.
And then 4 over 2.
2,
Wait,
1,
what?
4,
Over 2.
2,
And then,
8
oh,
over
there we go.
3.
8 comma 3. Exactly. And I'm going to use Chris's observation, which is, hey, they're just switched. So you're getting too far ahead of me because you guys are too smart. An inverse function switches the values of what and what. Quiet raise hand. I'm going to choose Chris if he has it.
You just
X and Y.
X and Y.
Okay, I was done.
It switches these values x and y. So you can kind of do like a diagonal function. This goes here. This goes up here. You switch these two. And if I'm talking about the formal domain and range, domain again is all possible values of x, and range is all possible values of y, it actually switches the domain and the range. So the range becomes the domain becomes the range. All right, and this is trying to connect yesterday's lesson back in. Say I have this function y equals 2x. Y equals 2x right here, y equals 2x right here. I'm still talking about the same function, y equals 2x, that multiplies by 2. We went 1, 2, 4, 8, 16, 32, on and on. I'm going to use the definition here of an inverse. This is a second definition of an inverse, by the way, because we already defined it up here. We said it just reverses the function, and it also just switches the x's and the y's. I'm going to use this definition and switch the x's and the y's. So instead of a y, this is now, shout it out. Instead of a 2 to the power of x, this is 2 to the power of
Y.
There it is. Write it down. This is now the inverse function. Give yourself room, just like I did, because we're about to do something special. I think I'm just going to give all of you guys 100 XP. All right. So the inverse function not only switches the x's and y's, but you always have y equals something. So that means you're solving for y. But that is a problem. How do I solve for y? It's trapped. It's trapped in the exponent. You'll be thinking about this on the final and the test later today, or later, not today, but later in this unit and later on the final. Wait, it's trapped in the exponent. How do we get it down? And that's kind of this big idea for this lesson. How do we get this trapped y down? And what are we studying this unit? That's our answer. Logarithm is how we undo it. Are you ready? Here is the key. This is the key. To undo this 2 to the power of y, I'm going to do log base something. What would our base be? Take a guess. Someone take a guess. Gio. Good guess, but not quite. It is one of these numbers.
Oh, it's a number or like an exponent?
I kind of gave it away then, didn't I?
Bro, call it 2.
2, yeah. It's going to be log base 2. I'm going to take log base 2 of both sides.
Wait, why do you do 2?
Because 2 and 2, these two match up.
Oh.
So it'll always be that number?
Log, it will always be that number. To undo it, you always do base of the base. I mean, this was base 2, so do log base 2.
Wait.
If I say 2 to the power of x, the base here is 2. If I say log base 2, the base is 2. They have the same base. If they have the same base, they will cancel each other out.
Oh, that's like just
Okay,
and then you get
so let me ask this really cool question. Are you ready for this?
Shoot.
2 to what power is 2?
1.
0.
This whole thing right here is 1. And there's another trick that I'm going to have to show you tomorrow, but these all cancel each other out, and y is no longer in the exponent. Y now comes down. This is how I write it. Let me come back here to a new color. These cancel each other out. All of those are gone, and I'm just left with y. Y is no longer in the exponent. It is now down in the base. I have canceled it out. I have brought it down, and y is equal to log base 2 of x. This is it's starting to give me goosebumps because we have found this red function. This red function is the inverse of this blue function. We didn't know what it was before, but now we do. This function is y equals. Write it down on your graph. This function, we just found it. The inverse graphically is reflecting over the line y equals x. This is y equals log base 2 of x. Again, we did not know in our table what this y value was, but now we do. We know that this value is log base 2 of x. We know what the graph is. We know what the table is. And finally, the rule. I'm going back to the rule that we started yesterday. Our rule stated, if I have log base b of y is equal to x, that was called the logarithmic form. Write it down. Logarithmic form. That changes to the exponential form. Exponential. Ran out of room. Exponential. I can't write exponential form. What is the exponential form of this? Who remembers this? How do I change from logarithmic form to exponential form?
B.
B. Oh, careful. Just using b, y, and x now.
Squared x
B to the power of x
equals y.
equals y. These are inverses of each other. Well, I shouldn't say that they're inverses, but they're the same form. I mean, you can see that this form right here looks like this form right here. You can see that this form right here looks like this form like right here.
Okay.
So far, so good?
Yeah.
I have gone over all 3 homework problems, but I haven't done examples yet.
Yeah.
Yeah, the.
I was like, oh.
Let's see if we can do that.
Oh, this is
Wait,
what's the
there's
homework?
There's one homework problem.
Wait, what?
There's one homework problem on Khan Academy.
Assignment?
There's one assignment, yeah.
Oh.
Oh, one problem.
Sorry, yeah, it's one assignment.
Okay, this one is
All right.
a really big problem.
I have a graph y equals 3 to the power of x. I need to graph 3 points that should be on this function log base 3 of x.
Okay.
Who's got those 3 points?
Uh,
Gio, give me one of them.
0, 1.
0, 1 is this one.
Yeah.
So what should be on log base 3 of x?
Yeah, I don't know. Okay, so I can put what is it? 1 over 3.
1 over 3, yeah.
1 comma.
It's 3,
And last one's 2 over 9.
Well, okay, yeah, so you're listing this one. This one is 0, 1. I need to list something down here. There's going to be a log function down here.
1 comma 0.
1, comma 0.
Oh.
Mhm.
Go back. It's so much fun when you understand. I know. When you guys are like, oh my gosh. my
All right,
gosh.
thank you, Stego. What's the next one going to be?
3, 1, comma 1.
Yeah.
3, comma 1. Because this was 1, comma 3, it's now 3, comma 1.
And then the last one's 9, 2.
9, comma 2. Write them down. All you have to do is change the x's and the y's because that is an inverse function. Log base 3 of x is the inverse function of 3 to the power of x. Again, I'm always coming back to our standard because that's how I'm trying to format this lesson, this whole unit. Our lesson today is trying to understand that logarithms are the inverse of exponents. We know a lot more formally now why they're inverses. Graphically, they're the inverses because you're reflecting. Tabularly, they're the inverse because you're switching the x's and the y's. Algebraically, they're inverses again because you're switching the x's and the y's and you're solving. Let's try another one.
Do we have to connect the dots?
You don't. Nope. You just have to graph them. Graph those dots.
Yeah, I can do straight little words.
All right. So I need to rewrite this log form into exponential form. Who can do that? Fiona, go for it.
Wait, I take it back.
Okay.
Yo,
Bro, when did I swear we did not do this yesterday?
What is that? Wait.
You like me and like do the same exact thing.
Oh, wait, this is
I do it in
Yeah.
Spanish instead of Mandarin.
Really?
log
You should see, bro. I was like, dude, the worksheet we were doing last time, that was for what? It was like,
1 over 81
like, dude, I would go for a little bit, write something else, like stuff.
equals negative 2.
There it is.
So you're turning the exponential form to the
Log form.
log.
You should be able to go backwards and forwards by the end of the lesson, by the end of the homework.
It'll just take me a long time.
Yeah, I know. It definitely does, yeah. That's the reason that I assign homework, is so that you get to practice with this idea. All right.
The answer, or?
That's the answer, yeah. That's log form.
Oh,
Okay, well, that's only half of example 2. The other half is doing this one in exponential form.
Oh my god.
So let me come back and give Fiona her XP.
You got you, right? So you.
I want to give it to someone aside from Fiona. Fiona, go ahead and do it. Do the problem. Write it down and you can check it against us. If you already know how to do this, write it down. Who wants to volunteer to do it?
Can I give a guess? But I'm wrong?
Go for it, yeah.
So. Okay, so.
Be nice.
No, I didn't want
You know
to
what?
do it. Is it-
All right, what's the base, Chris? I always start with the base. This was base 9. This was base 9.
Is it 8? It's half.
Base 9.
Can I do it?
So 1/2 is the base. What's the power?
8.
What power? The answer is -3. This, again, is a what power function. What power does 1/2 need to be raised to get to 8? 1/2 needs to be raised to the power of... Chris, the answer was?
-3. I said that.
You said that, yeah.
You just have to say it again.
You didn't say anything, so I thought it was wrong.
1/2 to the -3 is equal to.
Eight.
There it is. You have to be able to go back and forth between logs and exponentials. So,
Wait, my exp.
yes. One thing I'm going to make a note before you go on to the homework also. Oh, that was the wrong button. I'm going to come back here.
Yeah.
Just give you another 30.
Me? Or you're the one at 12.
One thing that I will point out here, and I want you to write this down as well. This 9 is called a base. This 9 is also called a base. Because they're the same number. I mean, it's base 9, base 9. This 2, this -2, is called a power. To the power of -2. And again, this whole thing, this logarithm, was asking what power does 9 need to be raised to get to 1/81? Well, the answer for the power that gives you 9 to 1/81, this is the power. This is the answer. This is the power that will make it so that 9 to this power gives you 1/81. And our answer, I'm going to call this the answer because there's not really, well, there might be a formal word, but I forgot it. This is going to be called my answer. 1/81 is my answer for 9 to the -2. That means 9 to what power gives you the answer of 1/81. This thing is the answer. You should still, in the back of your mind, be thinking of logarithms as what power functions. What power does 9 need to be raised to get to 1/81? Well, 9 needs to be raised to the power of -2 to get to 1/81. And then finally, example number 3. Fill in the missing values for the table below. So note, Mr. Sindel made a mistake. This is what I was working on when you guys were doing the warm-up, was getting these two tables done. Can we please change this function right here? Scribble this out. This should be y is equal to log base b of x.
Wait, what is that?
This should be log base b of x. So that means that these two should be inverses of each other. All right, 1.5 goes to what value here? What is the y value? Quiet raised hand. Stego.
30.
It is indeed 30. Because if I flip this one, this now becomes 1.5 for the x and 30 for the y. So that's how we know we're correct. Thank you, Stego. And then finally, what is the y value for 20, Chris? Yep, 1.3.
Alright, cool.
All right, give yourself another assessment out of 4. How well do you understand that logarithms are the inverse of exponents?
Yeah, I said something.
Solid 4, solid 2, 3. Fiona, Teflon, where are you at? You can't be a 5 out of 4. Okay, you can be a 4 out of 4.
I don't know.
Teflon, how well do you understand that logarithms are the inverse of exponents? A 3 out of 4? All right, sounds good. Hopefully by the quiz tomorrow, we're going to be at a 4 out of 4.
Ready?
That's fine.
All right, yeah, that concludes this. Go ahead and write your summary now. And by the way, there is a new way to assess how well you have been participating. And I'm going to be printing this out for you as well. I spent quite a bit of time trying to figure this out. For the warm-up, what would you guys consider yourselves? What level of effort were you putting forward? This is a chart for effort. Were you at 1, 2, 3, or 4 for the warm-up? Which describes you the most? Did you circle a bunch of things for number 3, a bunch of things for number 4? Hold up your fingers. Which describes you the best for the warm-up?
Oh, for the warm-up?
For just the warm-up, what level were you? 1, 2, 3, or 4?
Maybe a 3.5.
Let me see fingers. What level were you for the warm-up? Were you a level 1, 2, 3, or 4? How hard were you working on the warm-up? Okay. Let's see, how hard were you working for the lesson? Look and read these. Barely got distracted, tried solving most of the example problems with as little help as possible. You just closely follow the lesson. You tried each example problem with as little help as possible. You wrote a thoughtful summary with all of the important points in all of your own words. And then did you also offer help to people that needed it? What level were you? 3, 4? What are we at? And you're going to be doing this every day, so get in the habit of doing this. And then finally, this is what I'm going to be looking for when you're working on the homework. A level 4 means that you are immediately starting working on the homework. You gave 100% focus. You don't get distracted. You did the homework multiple times to get a 4. Notice that a 3 is only finishing the homework once. 4 is multiple times in order to understand it. If you think that you're a level 4 out of 4 for understanding, I'm okay with you doing it only once. But usually you should be doing it as many times as you need to understand. Not to get 100%, but to understand. And then also offering hints and guidance to people that need it. All right, so you're going to be doing homework right now. Be shooting for the 4 range. That's the best you can be, a 4 out of 4.